طيب، بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف خلق الله سيدنا محمد وعلى آله وصحبه ومن والاه. معكم الدكتور زهير أوان، أمين الجمعية السعودية للكيمياء الحيوية السريرية، الكيمياء السريرية. بادئ ذي بدء أود الترحيب بالحضور اللي وصل تقريبا 1500 في السيشن الأولى، والآن قارب على 1000 تقريبا. ويسعدني انضمامكم لعضوية الجمعية السعودية لكيمياء سريرية في المستقبل القريب بإذن الله. هذه الأمسية العلمية بمناسبة International Laboratory Week on Quality. This seminar is organized by the Saudi Society of Clinical Chemistry and the Saudi Quality Council, endorsed by the Saudi Council for Health Specialties, and in collaboration with the International Federation for Clinical Chemistry. After the first session, which was on standardization, we will have our second session on accreditation, which is a very normal progression from standardization to accreditation. We will have our first lecture by Dr. Walid Al-Tamimi. I just remind you that we will be deviating a bit from our usual, where he will deliver his first presentation and will take immediately questions. So please submit your question in the chat room. So without further ado, I would like to introduce Dr. Walid Al-Tamimi. Dr. Walid Al-Tamimi, he is the former president of the Saudi Society of Clinical Chemistry and a founding member. He is the head of Clinical Chemistry Lab at King Abdulaziz Medical City. He is an associate professor in the College of Applied Medical Science at Saudi University for Health Sciences. He's a board certified from the National Registry for Clinical Chemistry, and he will be talking about how to prepare your laboratory for accreditation. Without further ado, again, we welcome Dr. Walid Tamimi, and the floor is yours.
Bismillah ar-Rahman ar-Rahim. Just to know that everybody can hear me now.
Loud and clear.
Can you hear me now?
Clear, Dr. Walid.
Clear وين يا دكتور؟ ماني شايف clear.
We can see your presentation, the first slide.
Can you see the presentation?
Yes, we can see it.
Can you hear me?
Clear. Your voice is clear. Please start.
Okay. Bismillah ar-Rahman. Thank you very much, Dr. Zahir, for the introduction. And thank you for giving me the opportunity to be with you. We hope to learn together from these sessions for quality. And my talk will focus on how to prepare your lab for CAP inspection. I know it's a long journey, but we would like to share some of basic experience together. And we hope to learn for more in the discussion maybe, or later on we can present a more practical session. So I work, as Dr. Zahir mentioned, in King Abdulaziz Medical City, Riyadh. I brought this photos because I want to show you the old hospital here, we call General Hospital, where it was the second lab in Saudi Arabia to achieve the CAP accreditation in 1986. Now this is a complex that was started by 500 beds, but this now hospital or General Hospital is 1,000 bed, and we have Children's Hospital at the back of this photo, which is about 300 bed, and the ER 60 60 beds in the ER, and we have trauma center. So it becomes like a medical city. And also the university on the left side. I can show you more photos about the university, where you have all health colleges in this university. And you can see with the red arrow is the our central laboratory, the new central laboratory, where it is in the middle of this complex. This is the central lab, which is about 12,000 square meter, and it's about 500 employees, and CAP since 1986. Inside this building, also happy to mention that we have the core lab, the total lab automation, where you can see the hematology line and the chemistry line and the immunology line with the pre-analytical and post-analytical, receiving about 6,000 samples per day. So CAP stands for College of American Pathologists, proficiency testing, PT, lab is a laboratory accreditation program, and QMS is a quality management system, CMS is a Centers for Medicare and Medicaid services in the United States, where they have all know about the health system in the United States, where the CAP is part of this, because we talking about the College of American Pathologists, we should mention the system that they create the rules and the guidelines for health system. Quality control, everybody knows that, and preventive maintenance as well. The lab accreditation program, LAP, of the College of American Pathologists, CAP, is an ongoing activity to improve the quality of clinical laboratory services through voluntarily participation, peer review. You can compare your result with the peer with others, education, and compliance with performance standard. One of part of this is having checklists and follow up the checklist in your laboratory. We will talk about that later. So what is the accredited lab? It is a lab that is inspected by a private non-for-profit accreditation or organization that has been approved by the Centers of Medicare and Medicaid system in the United States. Example of this accreditation is CAP Accreditation, because there are some other accreditation organization in the United States. If you decided to go for another accreditation, it should not be from the United States. Like, for example, we have SBAHI, our local accreditation organization that can accredit your lab as well. But because of the, we are talking about the CAP accreditation in this presentation, we will just only mention all relevant information regarding CAP accreditation. And again, the history of CAP, that American Society of Clinical Pathologists, as established in 1922, and American Board of Pathology, established in 1936, and College of American Pathologists, the accreditation established in 1946. This College of American Pathologists is an advocate for high quality and cost-effective medical care, and is widely considered the leader in the lab quality accreditation. There are about 7,000 laboratories are CAP accredited. 23,000 labs are enrolled in PT program. So you can see the differences between accredited lab and those who only use the proficiency testing. Bear in mind that having the proficiency testing doesn't mean that your lab or the other lab is accredited. You must have the accreditation, and accreditation cannot go without the proficiency testing. So the mission for the College of American Pathologists and Laboratory Accreditation Program is to improve patient safety by advancing the quality of pathology and laboratory service through education and standard setting and ensuring laboratories meet or exceed regularity requirements. The vision of this organization is to be the world leaders in innovator in laboratory accreditation. Examined pre-analytical, analytical, and post-analytical aspect of quality management in the laboratory, which include test methodology, test specification, reagent control, media, and so on. If we break down these to pre-analytical phase, analytical phase, and post-analytical phase, and we go deeper on each step of these are having standards that being created by the laboratory accreditation program that provided by the College of American Pathologists. In addition, it also examined organization the lab, and make sure that the lab is part of the organization and it's occupied a clear role in the organization, a chart, personal requirement. Check the personnel or staff who running the laboratory, ensure that the safety is number one in the laboratory, document control and management, corrective action, preventive action, and continual improvement. That part of the laboratory accreditation program provided by the College of American Pathologists. So what are the standards for the CAP accreditation? Number one standard is director and personnel. Number two, physical resources. They have to make sure the director and personnel are highly qualified, and the physical resources are, including the safety, are comfortable and convenient to provide the service. Standard 3 is the quality management. It has the lab accreditation or CAP accreditation must ensure there is a quality system, clear and effective and efficient to provide the highly quality result. In the number 4 standard, the administrative requirement. The specifiers of how the standards are applied to the laboratories are found in the CAP accreditation checklist. This is one of them, is a checklist. There are about 20 or more checklists in each discipline of each lab, including general, leadership, checklist, safety, and so on. And it's available from the laboratory, from the website of CAP once you have registered. So how accreditation help our lab if we go for this kind of accreditation? You will have comprehensive evaluation every year, or at least whenever you want to do mock inspection. You will be confident of what you are reporting. You will ensure your client that what you are reporting is under control of non-profit organization that monitoring your quality and monitoring your performance. This result should be always accurate because of this accreditation. Lab should maintain high level of services. Expert inspection team multidisciplinary teams of lab professionals will come to the laboratory. You will benefit from those who come to you. They will learn from you, and you will learn from them. Thoroughly inspect every specific section. People go for HLA, flow cytometry, clinical chemistry, microbiology, and so on. It is a useful inspection tool where it is customized inspection checklist. You will see the standard, you will learn from the standard, and you will be able to monitor, report in accurate manner a good quality result. Also, there will be a compliance with the regulation. For example, if you take the CAP accreditation, SBAHI will be like rule of thumb. It will be easy for you to be accredited by SBAHI, because most of these are regulations are found in both organizations. Helps you to meet and exceed in the United States the Center of Medicare system requirement, including CLIA, which is the law of laboratory, unparalleled education opportunity as an exchange of idea and discussion, valuable inspection at the end, and recognition as a top performer. Whenever you have the accreditation, you will be given advantages to be superior to those who does not have any accreditation. There will be leader committed to quality patient care, and about 83% of top hospital community choose CAP in the United States. So now you want to start after all that benefit, and you know about the CAP history and what are the CAP accreditation. You want to think or to suggest to your administrator, hospital administrator, that you want to go for CAP accreditation, and that part has been approved by the administration, and then you want to prepare yourself and your lab for this inspection, CAP inspection. Always think like an inspector. Thinking like an inspector during your preparation will make your inspection run smoothly and with fewer deficiencies. For example, if you think that the inspector come to you and ask about KPI, you ask yourself, are KPI established in my laboratory, key performance indicator? For example, one of them is a turnaround. Do I have a data for turnaround time? Can I see this? Because the inspector will ask this question to you. Can I see your KPI if you have it? And then look at it deeply. Does it tell you how is your performance in reporting the result in a right pattern? Check the routine, check the stat. So always ask the question to yourself as an inspector and try to find the answer. This is important. For those who want to go deeply, first of all, they have to go to review the checklist. Every checklist has standard, and each standard represented as a question. So the question is being asked yes or no or not applicable. So if it's yes, then it has to be documented and compliance. You have to show the evidence that it's been in compliance manner. Always check in the checklist there is a new or revised questions. Conduct a mock or self-inspection, which is easy. You can call your colleague. You can organize this after you do prepare all the standards. Ask your colleague to come and do mock or self-inspection. Centralize important manuals and documentation. You need to know where they are before the inspection or the inspector start the inspection. Annotate or write short notes on the checklist. Always write, because you will remember when you read the checklist where you put the documentation, and some answers has to be near the standard so you can answer the inspector. Watch supplies and reagent. Assign one person to take responsibility in each lab area. Don't forget the part-time and backup staff. Call them. Let them be part of the inspection, including the full-time, of course. Maintaining continuous improvement, education, and improvement of the quality. This is by the CAP, the cycle of, if you can see it, the step to prepare your lab before the inspection. So we will go in detail in each one of these, but there are the 10 up to from 1 to 9. It takes about 1 year, and then from 9 to 10 is represent the second inspection after you do the first inspection, and you will do in the next year a self inspection and report it to the CAP. But if we go in detail to each one of these steps, request on application from the website or the CAP. So and bear in mind that international laboratory must be enrolled in CAP proficiency testing, external quality control assurance for a minimum of 6 months before requesting an application. And this is the case in all of us. So if you decide to go for CAP accreditation, you need to buy the proficiency testing from them and enroll in this for 6 months before you apply for the preparation of CAP inspection. So the first step is to buy the CAP proficiency testing and run it in your lab for 6 months. And then after that, you apply to get the application from the CAP website. Second, after you get this, you apply, they will send you review welcome kit, which is review the electronic welcome kit and additional information on how to get started with the accreditation process. They will show you the step how to do your accreditation or inspection. Number 3, complete application. Look into electronic lab solution suite to complete the application within the 3 months. Then you will receive customized checklist. Review your customized checklist. Each organization has its own customized checklist, because in some laboratory you find some service, and in another you don't have this service. Some lab has, for example, toxicology lab, some other doesn't have, so they will customize the checklist according to your service that you have. Also, you can identify any gaps in prepare for your on-site inspection. Schedule inspection date. Normally, it takes about 3 to 6 months from receiving the kit. So you will have about, now if you are international lab, you will have 6 months enrolling in proficiency testing, and then you apply, and then it will take 3 to 4 months before you determine the date of first time inspection with the inspection team leader. All recurring inspection are unannounced in the United States. But subsequent inspection for international and specialty accreditation program are announced. So in the United States, they don't announce the date, but the lead, the head, and or the director and the inspector know the date, and they, when they come, staff will be notified in the first day. The inspection. But this is not the case for international. The international, laboratory will be notified and announced in advance before the inspection starts. During the host inspection day, there will be welcome the inspection team and assist the inspection logistics. Your inspector will provide a copy of inspector's report during the summation conference. Summation conference is the conference or the meeting that will be set at the end of any CAP inspection to announce if there is any deficiencies or recommendation and the successful or failure of the inspection. Respond to deficiency within 30 days if there is any deficiency. Review your report and respond to all deficiency at the same time. So they will give you 30 days to finish any deficiency. They will leave you with the deficiency and you will do them and rectify any or solve and correct any problems or deficiency. Support CAP review responses. If sometimes they will respond back to you. Work with CAP technical specialists in any follow-up questions and anticipate your accreditation decision within 75 days. You will have more time also to respond to any question. Receive certificate of accreditation and then the CAP miles the certificate to the attention of the laboratory director. They will send it, email it. The initial inspection date becomes the laboratory anniversary date. So if your inspection was like today, 7th of March, then next year you have to do another inspection. So after 2 years of the beginning, 1 year from the on-site inspection, then you will do self-inspection and maintain continuous compliance, receive materials from the CAP and conduct self-inspection on your laboratory anniversary date. Keep the lab information up to date by logging into eLab Solution suite at the CAP site. The packet that comes to you, the welcome packet, has to have the test activity menu. I will show you an example. It has to have the organizational chart that you have submitted earlier. It has to have variant proficiency report during the last 6 months that you have done or 9 months. Previous deficiencies, if any, if you do it for a second time, if the first time you will not have this. Inspector submission report also of the previous inspection. Deficiency and recommendation page. It will be empty and checklist that customized to you. There are some pre-assessment phase that you must submit an application request form, laboratory section page for each, and personal form for lab directors, pathologists, quality personnel, etc. Supplement material like CV, organization chart that you have to submit it before the kits come to you. Must enroll MVT program for each patient, reportable test and for affiliated labs. You must list all lab disciplines, like you have laboratory general, transfusion medicine, chemistry, hematology. Must provide lab activity menu, scope of testing that you have, how many tests, your test menu, list of all reportable assay. I'll show you an example of this. This is an example of test active menu where you report you have proficiency testing or no, because sometimes the CAP doesn't have the proficiency testing for this test, and you have to find alternative to this test that you submitted. Pre-assessment phase and information provided is critical as it will be used to customize checklist. After processing the application, CAP will send the customized checklist to the lab. CAP inspector will use the same version of customized checklist. So you will read both. You will read them from the same book. The CAP checklist is a list of requirements to determine if the lab meets the standard. It's a question. They have 3,000 standard or question, instrumental to guide the inspection and interpretation. There is a cover about 3,200 requirements which indicate current lab operation. The CAP checklists are different. You have lab general, hematology, clinical chemistry, and so on. And this is the CAP all common checklist. For example, general, this is how it looks like. And it's helped paint a complete picture of the lab current operation, provide guidelines of development, policies, procedure, and process, help ensure accurate, reliable test result, customize type of deficiency of each requirement. And there are phase 0, phase 1, and phase 2. Phase 0 does not require formal response, and phase 1 does not seriously affect the quality of the lab, and normally the response takes 1 year to rectify or correct the problem or deficiency. But most important, this is an example of phase 1, when critical results are communicated verbally or by phone. Is there a policy that laboratory personnel ask for verification of readback of the result? And by the way, that was phase 1, and the question not applicable, yes or no. It's been, of course, you can answer no, and it takes 1 year to convert it to correct this problem. By the way, this has been moved to phase 2. Phase 2, as I said, it may seriously affect the quality of patient care or health and safety of the hospital and must be corrected immediately. This is an example. There is a policy that prohibits referral of proficiency testing specimen to another laboratory, and the answer has to be yes. It must be yes. Otherwise, it will be deficiency and has to be corrected immediately. During the assessment phase, the inspector will look at the time of documentation, quality record, proficiency record, and instrument maintenance record and procedure manual. And also will ask open-ended questions as a starting point to obtain large amount of information, help understand the documentation. And example of this is to read the documentation, observe, and then ask. And we call it ROAD, including discover. You go and ask and discover. So it's abbreviated as ROAD, or stand for ROAD abbreviation. It's an open-ended probing questions, and when the inspector side deficiency, no policy not being followed, incomplete or absent documentation. I am finishing now. When the inspector to give a recommendation, compliance is not an issue. Suggestion for improvement need not to be related to specific checklist question. And then post assessment, they will be responding to the deficiency, and then will give you the accreditation, and you have to maintain the accreditation, of course, by participating in proficiency testing and doing the. So in my last slide, have the support of your organization at higher authority level to achieve this goal, accreditation, involve as many staff as possible in preparation of the inspection, ensure that all CAP requirements have been implemented, make sure that staff are aware and participating of a written policy and procedure. Don't do it yourself. Ensure that every assay in your lab has proficiency testing, external quality control system. Thank you very much for giving me the opportunity and for your attending attention.
Thank you very much, Dr. Walid, for this comprehensive presentation about getting your lab accredited. Unfortunately, we have only time for 3 questions. The first question, what is the difference between validation and verification?
Okay, this is very, very good question. When verification normally has to be done if you have a new assay or developed assay. And this is what we also received from the manufacturer. They do the verification. They do the validation, technical validation. For verification, it has to be done by the lab personnel when you receive any new instrument, and do minimal component of the validation. You don't have to do all the validation steps. There are maybe 10 to 12 validation steps. You are not necessarily to do it all. You do only to verify and verify that the validation is as being correct as has been claimed by the manufacturer. So you do the verification. You do accuracy and precision, not everything. You rely on, for example, about the interferences that have been done by, because you cannot do it by yourself. You can't verify the manufacturer reference range and so on. Very good questions, and always people messed up between these two terminology. Bear in mind also there is clinical validation, which has to be done by with our colleagues, the clinician, to ensure that the results are reporting correctly.
Thank you very much for your answer. The second question, can you talk more about staff qualification in lab accreditation?
Okay, the CAP, if we talk about the CAP or any other accreditation, they require that staff has to be, normally they go for leader, not for every, because they know technician can have diploma and the specialist can have a bachelor degree, but they normally go to the supervisor and the director. The director of the laboratory has to be board certified, has to be PhD or MD or both. For the supervisor has to be accredited or have a license. They prefer that the supervisor has to also have a master's degree in addition to his bachelor degree. Otherwise, experience is enough.
Okay, thank you again for your answer. The third question, probably the last one. What is the cost of CAP accreditation in a lab in Saudi Arabia? And is it including the accommodation and hotel and transportation?
Of course, when you go to lab accreditation, as we all know, that quality is high price. You want to make sure that your laboratory is in compliance with the high standard. And to the best of my knowledge, I don't have the answer to how much it costs. Proficiency testing, when you buy or purchase this proficiency testing, it will cost you some money, but in return, you will benefit from this proficiency testing, because you will compare your result with other colleague or other laboratory. It will give you a confidence. It will give you approved for your colleagues when they come and ask about the reliability of your result. So you have to make sure that you have a documentation and system to ensure the quality in your laboratory, no matter how much that costs. But you have to use it in an efficient and effective way.
Correct me if I'm wrong, but it depends on the scope of your service and what test you want to have CAP accreditation for. Again, it depends on what you want to accredit. Do you want to accredit all the scope of service, or partially, or completely?
Yeah, if you able to accredit 85% of your lab service, that means that you have covered most of the service in the laboratory. However, some developed testing that may not be covered, and you can also report it as it's not under CAP accreditation, and you do some clinical validation on that. Sometimes this is not available in proficiency test from the CAP, and you have to buy it from another sources.
Thank you, Dr. Walid, for your complete answer and very informative session. We have to unfortunately move on to the second. Thank you. So our second very elegant speaker will be Reem Abdel Majid. She's a senior medical lab specialist and total quality manager specialist. She's a member of the pre-analytical working group and antimicrobial resistant group in Saudi Arabia. She's a previous supervisor lab specialist at King Saud Medical City for flow cytometry. She obtained her bachelor degree in clinical laboratory from King Saud University in 2007, and her master from Alberta University in Canada 2014. And she's going to be speaking to us about laboratory safety, a very important component of accreditation. Without further ado, please, Ms. Reem, the floor is yours.
Yes, hi, hello everyone. My name is Reem, and I'm a quality specialist and safety officer at the Prince Sultan Military Medical City. And today I will be talking about the health and safety in laboratory, specifically in the lab inspection. So as we all know, lab environment has lots of hazards and that threaten the life of the lab personnel. So our main goal is to provide a hazard-free environment, and this can be conducted by doing a safety inspection on a regular basis. So inspections are the principal method of evaluating lab safety. And conducting self-inspection, as I mentioned, is very essential to provide a safe working environment. So regular inspections of all laboratory must be conducted, and usually this is done by the safety officer or the safety representative. So these inspections must be done in accordance with the national and international agencies that set the safety guidelines. Most commonly, we have CBAHI, we have the College of American Pathologists, we have the JCI, we have the CLSI and OSHA. So the purpose of having a safety inspection is to assess the safety program in our laboratory, to identify any safety and health concerns, and to comply with the regulatory requirements. Basically, this inspection is conducting in the area where they handle chemicals and biological materials. So, and also the results and the records of the inspection must be documented in each laboratory. So to conduct the safety inspection, first, we have to understand and to set the general safety guidelines. So it's very important to understand that the safety in the lab is everyone's responsibility. So, some of these guidelines is first having the safety policies and procedure. All the staff in the lab must understand and acknowledge the policy and procedure, and they should know where exactly it's located inside the lab. And the instruction of the safe work practice must be included as part of the new employee orientation to reduce any hazards associated with the lab, as the inspectors will interview the employees regarding their knowledge about the safety issues, and they can get this knowledge from reading the policies and the procedures and attending the new employee orientation. So as well, any lab incidents or injuries must be reported and recorded. Staff must know the location of the lab safety equipment, including the safety showers, eye wash stations, first aid kits, spill kit, and fire extinguishers, as they may ask where exactly they're located. And as I mentioned, all the records of any injuries or incident in the lab must be documented. So along with these general guidelines, all the lab must have good personal habits. These includes eating, drinking, and mouth pipetting are prohibited in the lab. Each lab should have a sign indicating that as no food or drink or any electronics. Keep the hands away from the face, mouth, and eyes to prevent any contamination. Do not put any objects like pens or pencils or pipettes in the mouth while you're working on the bench. Food and beverages must never be stored in the lab fridges or freezers. Even electronics must be prevented while working on the bench, specifically cell phones. Maintain clean lab to reduce the risk of any contamination, and all the labs should have a warning signs indicating that. Along with the personal habits, housekeeping habits must be followed. All working area must be clean and neat, including benches, hoods, and sinks. Any chemical spills or splash on the equipment should be cleaned up immediately. Unused chemicals containers must be closed and never store them on the floor or under the sinks. Working area should not be clustered with equipment. All hazardous material should be stored properly, and never obstruct doorways, hallways, and the access to the emergency equipment with anything. As we see here in the pictures, we have some bad housekeeping habits. All the chemical bottles here are stored on the floor. We have the safety equipment here is obstructed with some of the boxes, so no one can reach it very easily. Also here, the eye wash station and the fire extinguisher is also obstructed. The personal protective equipment is very important. They are defined as a specialized clothing or equipment that is used for protection. All employees should understand and should know the appropriate PPE that they have to use while working in the area, and all supervisors must assure their availability in the lab. All employees who is working with blood or any blood substance should wear the appropriate PPEs. This includes gloves, lab coats, gowns, masks, and goggles. Employee must wear lab coats and avoid wearing any loose clothing. Even they have to wear a closed shoe, prevent using sandals or open-toed shoes. So along with the PPE, all employees must receive the proper training in two aspects: hand hygiene and the wearing and doffing of the PPEs, which I will explain it now. So these are the required training. First of all, the hand hygiene. It consists of hand rub and hand wash. So here we can see the hand rub, which is the use of an alcohol substance, and usually it takes from 20 to 30 seconds. Usually you have to have a plentiful amount on your hands, and you follow all the steps for the hand rubbing, palm to palm, on top of each hand and between fingers. And then you let it dry. In the hand wash procedure, you use soap and water, and usually it takes from 40 to 60 seconds. You wet your hands first, and you add the soap, and then you follow the same procedure for the hand rub, and then you wash it with water, dry with the towel, and you turn off the water faucet with the towel, not with the hands. And for the PPEs, all the staff should understand and know the sequence of putting on the PPEs and taking them off. So for the donning of the PPEs, first of all, they have to perform any of the hand hygiene procedure. Then you have to put on your gown, mask, goggles, and at the end you wear your gloves. For the doffing, it's the other way around. You have to remove the gloves first, then the gowns, then the goggles, mask, and then you perform the hand hygiene. So there is lots of hazards happening in the lab, but today I will be giving you an overview of the most common ones. So we have a biological hazard, we have chemical hazards, we have physical hazards, electrical hazards, and lastly, fire hazards. So biological safety, it's very important. So to protect the employees from any biological agents. So all biological samples in the lab are considered potentially infectious. That means all the employees should deal with them with the high precautions. So these infectious agents can transmit through inhalation, ingestion, and inhalation. So the standard precaution must be employed when handling any infectious materials. All the employees must wear the appropriate PPEs. They have to have to perform the hand hygiene. They have to prevent the aerosol formation and spill by working under the safety cabinets, and by working under the safety cabinets. So we have different biosafety levels. It's related with the risk group of each microorganisms. So the least one is the biosafety level 1, which has a low risk in microbes. So this poses a minimal potential hazard to the lab personnel. Agents are not known to cause any diseases in adults. The work can be done on an open bench tops, but of course the appropriate PPE must be worn. For the biosafety level 2, this kind of organisms poses moderate hazard to the lab personnel and environment. So the lab working with this kind of biosafety levels have to have a restricted access. And the work must be done under the biosafety cabinet. For the disposal of the materials, they have to autoclave to decontaminate. And all the PPEs are required. For the biosafety level 3, these organisms considered as it poses a serious lethal disease via inhalation route exposure. Mainly we have the TB here. So these labs require the employee need a medical surveillance and immunization. And the access to this lab is restricted and controlled. It has to have a 2-door access lab. Work must be done under the biosafety cabinet, and the special ventilation system must be presented in the room as a negative pressure. For the biosafety level 4, these organisms poses a very dangerous and toxic hazards to the lab worker. So work must be done with the highest level of biological safety cabinet, which is class 3. The staff must changing their clothes, must shower upon existing and decontaminate all the materials before exiting the lab. Mainly these labs are located separated from the building. And decontamination system must be done for all the materials. Next, we have the chemical safety. Most of the chemicals they considered chemicals can be divided as flammables, corrosive, reactive, or chemicals that cause a health hazard such as toxicity and carcinogenicity. So all chemicals should be regarded as potential dangerous, and the lab must evaluate the hazard associated with all the chemicals and the mode of the transmission to the employee, so they know exactly what they're working with. Such information is available in the safety data sheet, and the safety data sheet must be available for all the chemicals in the lab, and it has to be accessible to all the staff. These SDS files contain the content and identification of the chemicals. It has the hazard information, the composition of the chemicals, the first aid measures, and the firefighting measures. So for any staff who's working with chemicals, he must consult the SDS file first. And for the labs working with chemicals must have a chemical hygiene plan, which is a written program that protects lab employees through policies, procedures, and responsibilities regarding health hazards associated with the hazardous chemicals used in the workplace. So a chemical hygiene plan has information about the protocol and procedures, hazard communication, chemical safety training, and the chemical inventory. And usually it has a 12th section, including these 4 aspects. So all the chemical containers must be labeled, and we have 2 labeling systems. The first one is called the National Fire Protection Association, which provide information for the emergency response to the fire and or any spills. So it has a diamond shape with 4 different colors. Each color represents a special hazard. For example, the red color represents the fire hazard. The yellow color represents the reactivity of the chemicals. The blue, the health is associated with the health hazard, and the white one has other specific hazards such as acidity. It also has a numbering system which indicates the severity of these hazards, starting from 0 to 4, which 0 is the lowest hazard and 4 is the major one. Another labeling system, we have the globally harmonized system, which define and classify also the hazards of each chemicals. So all the information is, these are the stickers which you usually posted on the chemicals, and it has all the information here based on the SDS. So it has 6 elements. It has a symbol or a picture. It has a single word, which usually it says danger or warning. It has all the manufacturer information, the first aid measures, it has the hazard statement, and the product name. Another chemicals most commonly found in the laboratories are flammable and volatile chemicals. So these kind of chemicals, we have to work with them very carefully. So it has to, the employees should work under a fume hood and use the proper PPEs to minimize all the chemical exposure. And for storing these chemicals, all the reactive chemicals must be segregated and separated away from each other to prevent any explosions. Flammables must be stored in approved safety cabinets, as shown here in these pictures, to prevent fire hazards, and they must be presented in certain quantities needed in the lab. The lab must follow the OSHA regulation regarding the carcinogenicity and the toxicity potential chemicals, such as the formaldehyde and ethylene oxide. Another aspect of the lab inspection, we have the electrical safety. So electricity poses a very dangerous hazard to lab employee, as they can cause electrical shock, electrocution, burns and falls. So all instruments and equipment must be adequately grounded. All the plugs and cords of the equipment must be in a good condition. Inspect the wiring of the equipment before the use. Prevent the use of the extension cords. Never obstruct the electrical panel. Do not attempt any repair to any damaged wiring. Just replace them immediately. Never overload the outlets, and don't touch the outlet with wet hands. Emergency shut-off switches must be labeled as well, so any employee will know where it is in the equipment. So here we have some of the examples of the electrical hazards. As you can see here, this is 2 extension cords connected to each other, which is called multi-outlet strips. Here we have an overloaded circuit, and here we have a damaged wiring. Okay, lastly, we have the fire prevention. Fire prevention plan must be written in each, it must be written so all the employee will know how to act in case of fires. So the fire safety training on the use and the response to the fire alarm must be performed for new employee, and this training must be conducted at least annually. Each staff must know the location and how to use the safety equipment, including the fire extinguishers, the fire detection system, such as alarms and sprinklers, and the fire blankets. So in case of fire, staff must remember the acronym RACE, which stands for Rescue Any Victims, Activate the Fire Alarm, contain the fire by closing all the windows or the doors, and extinguish using the fire extinguisher. So the fire extinguisher technique, we have the acronym PASS, which stands for pull the pin, aim to the fire, squeeze and sweep from side to side, try to put out the fire. As a part of the training, all the employees must know the emergency exit routes and the location of the assembly points of their building. They have to be aware of the first aid kit locations, and they have to report any incidents and keep records. Regarding the waste disposal, all the labs should follow the standards regarding the disposal of their waste. So waste, whether it's solid or liquid, must be disposed in compliance with applicable local regulations. Segregation of the waste should be in different colored bags. It depends on each hospital has a different segregation rules. Chemical waste disposal are controlled depending on the SDS. So the staff must consult the SDS file to know how to dispose such chemical. Infectious waste such as cultures, tissues, organ, blood, and body fluid are discarded into biohazard bag labeled leak-proof containers and must be incinerated or decontaminated before the final disposal. For the non-hazardous waste, like the plastic or papers, are not circulated, and this one can be disposed in the routine waste containers. For the disposal of the infectious or the hazardous waste, all the PPEs must be used. All the waste containers should be labeled as hazard, non-hazard, or biohazard, depending on what they contain. Regarding sharps, like needles, syringes, knives, razor blades, any glass, cover slips, or plastic pipets must be disposed in a puncture-resistant, leak-proof sharp container with a tightly fitted lid and appropriately labeled. Never fill the containers above the fill line and replace when in 3/4 full. So to summarize up, conducting regular inspection to identify the potential safety and health deficiencies and to assure the compliance with the applicable local and international regulations, assess and reduce hazards in the lab. All lab employees must complete all the required training. And that's it.
Thank you very much, Reem, for keeping with time. We have access for minutes. I think we should move on to the third and last speaker in order to have a final Q&A at the end. So without further ado, we would like to welcome Mr. Mohsen Al-Kurdi. He is the Medical Affairs Manager at Becton Dickinson since 2013. He is an application specialist in molecular at Abbott in the MENA region since back in 2011. He was a lab supervisor at Mega Lab, Jordan, in 2008. He obtained his bachelor degree in biotechnology and genetics from Jordan University Science and Technology in 2007. He is both an active member of the pre-analytical working group in Saudi Arabia and the antimicrobial resistant working group as well. He holds a black belt in Lean Six Sigma. He will be talking to us about the challenges of pre-analytical phase. Again, another important component of accreditation. Without further ado, please welcome, and the floor is yours.
Thank you, Dr. Zuhair. I really appreciate the introduction, and I would like, before I start my presentation, to thank and appreciate the effort of the Saudi Society for Clinical Chemistry. It's really remarkable efforts in the kingdom to improve the practice and drive the quality implementation. With this happy, I would say, event, I will be presenting the challenges of the pre-analytical phase and working successfully toward the ISO 15189 accreditation. I'll be covering in my presentation the laboratory errors and their impact on the diagnostic process or the diagnostic procedure, implementing a quality management system, quality indicators, the definition of quality indicators, and what are the key quality indicators in the pre-analytical phase. We'll be talking about the quality improvement measure or other methodologies in the quality which help us to standardize the practice and reduce the variation. And finally, we'll be talking about the change management and close the presentation with a summary. I wish I'll not be taking longer than the time which for my presentation. So start with the laboratory errors and their impact. We'll be talking about, as the dominant rule of the laboratory medicine growing in the diagnostic decision area and making, with even a limiting budget for the laboratory within the hospital, which, by the way, not exceeding than 5% of the entire hospital budget. With this very critical rule, the laboratory almost play a role in almost 70% of the decision making in the diagnostic process. All these practices led to more careful evaluating of the effectiveness and improvement in the clinical outcome. Looking into the laboratory or the cycle of the laboratory test, I know that most of you are familiar with the life cycle of the laboratory test. It starts with some biological disturbance or variation in the patient, and during the clinical phase, the physician will will start then, I would say, open the pre-analytical phase by testing, request the test or prepare the test order. Pre-analytical phase are well known by the most phase contain human interaction, manual steps, a lot of even basic steps, automated steps during this phase. The laboratory error exceed or up to 70% of the entire errors during the whole diagnostic process. After the pre-analytical phase, we're entering the analytical phase, which actually start once the sample or the analysis start on our sample. It's well known with the automation in the impact, the quality, as well for the quality and within the laboratory start in this phase. A lot of quality, external quality within this phase and quality indicators. Then moving with the post-analytical phase where we have initial interpretation in the lab for the result and interaction or convey the result to the physician via the LIS or the HIS. And then back the test or the result or the interpretation, the clinician and the patient treatment will start. Talking in more details about the pre-analytics, as I said, the pre-analytics start once the physician or the healthcare provider prescribe or start prescribing or writing the test. It's include as well requisition, preparation for the patient, collecting the sample, transport the specimen to the lab and within the lab sometimes, specimen handling and preparation for testing. Its end, actually, the pre-analytical phase will end once the examination or the analytical examination begun in the sample. A large part, it's a fun fact, large part of the pre-analytical phase lies outside the laboratory, beyond our control as the laboratorian. It's beyond the control of the laboratory. And most area or the most, part of the pre-analytics which contain a human interaction, and whenever we have unstandardized the human interaction, we're going to have the errors definitely. Most of the clinical laboratory focus into bring the latest technology, the standardization procedure, the improvement into the pre-analytic, but the part which is within the lab, we do see a lot of pre-analytical modules, automated, modules, standard procedure for sample processing, and we have improvement to the pre-analytical phase within the lab, but unfortunately not yet beyond the lab. Talking about the errors in the pre-analytical phase, I've listed some errors which we face during the pre-analytical phase. We have the wrong test order, we have inaccurate, incorrect patient preparation sometimes. We have collecting a specimen from the wrong patient, sometimes collecting the wrong samples, sometimes the wrong technique during collecting the sample, mislabeling the sample. It's unfortunately not that, it's fortunately not that much, but unfortunately we still have some mislabeling which could lead to a real fatal error. Incorrect sample preparation, lost specimen sometimes, and damage to reagent or to the test kit. Errors in the pre-analytical phase, as I said, around 70% of the error of the clinical laboratory error happened in the pre-analytical phase, which remain one of the most challenging area to standardize and improve and sustain, due to a lot of human interaction, no standardized procedure, no automation, real automation to cover this part yet. A significant part of the pre-analytical phase lies outside the lab, as we explained earlier. The laboratory bear the responsibility of recognizing the sample or the specimen once it's entered the lab. So the accessioning staff really need to know when they need to reject the sample, when they need to, because if they accept a sample with a non-equality kind of accepting criteria, then the to report a result, or will be responsible in front of the physician about the sample. So talking about implementing a quality management system, we'll start with the definition. Actually, it's skipping slides. We'll start with the definition of the quality standard of the laboratory. So standards for the medical laboratory within a defined quality management system provide the basis for optimal integrated of original organizational structure, process and procedure, and finally provide us a resource needed to fulfill a quality policy and thus meet the need and the requirement for the users. The most adopted quality external quality program we have today in the area of laboratory, we have the WHO, the World Health Organization procedures and standards. We have the International Standardization Organization, the ISO procedures and the standards and accreditation. We do have the Bible of the laboratories, the CLIA, or the Clinical Laboratory Standard Institution. And finally, we have the CAP, the College of American Pathology, which we heard a lot during Dr. Walid's presentation. The benefit of accreditation. Accreditation is a procedure by definition. It's a procedure by which an authoritative body give a formal recognition that the body or a person is competent to carry on a specific task or procedure. And we do, see a lot of stamps and logos on our laboratories or on the lab results. Sometimes the lab report shows that the lab is certified or accredited from this body, and that's mean that the person in the lab is certified to carry on a specific procedure. It's simply standardize the practice, which will reduce the variation and by the end, which will reduce the waste. What is the key reasons behind seeking accreditation, or why we have accreditation? So we do have a mandatory requirement accreditation. It's a mandate sometimes by the government, like what we have now in Saudi Arabia for the Sibahi. So it's a mandate by the government or by the Saudi Health Council to have Sibahi accreditation hospital or bodies or institution. It is even in US, and we do see in South Africa and in UAE now start to have forced accreditation, or accredited have to be. Some other times, it's the reason behind it is voluntarily to fulfill indications that compliance with the standard is desirable. Some other reasons, it's due to purely commercial. We see, due to maybe some tenders, some business requirement in order to agree with this laboratory, or to maybe insure. Sometimes from the insurance company, health insurance company, they request or they required from the healthcare provider to be accredited with certain accreditation program to make sure that they're providing up to the standard level, which at the end will, if all the healthcare hospitals are providing accreditation or standard procedure, will definitely enhance the overall spending on the healthcare. Competitive with the customer, meeting benchmark reliability, lab professional wishing to practice in compliance with the quality standards. Talking about quality indicator in the pre-analytical phase, we'll start again with the definition of the lab quality standard. Are the specific developed clinical laboratories. They take into account both the quality issues and competency needed to deliver the state-of-the-art laboratory So this is the lab quality standard definition. And the ISO 15189 in 2012 is specific. They have specified requirement for the quality and competency in the medical laboratory. And more details for the pre-analytics in the later slide. Of this standard, which used to clinical laboratory accreditation, require the implementation of a quality indicator, QIs, for the systematically monitoring and evaluating the contribution of the laboratory to patient care and identify of improvement opportunity. Another statement from the College of American Pathology, CAP, effective quality management program include monitoring of key indicators of quality in the pre-analytic, analytic, and post-analytical phase. The quality management section of the laboratory general checklist contain requirements of the implement of the quality management program and monitoring of the indicators. ISO have specifically specify a focus area in the pre-analytical area or for the pre-analytical phase. The key thing they have said about the pre-analytical phase to take care of or to focus on is the awareness of the test request, proper patient identification and preparation, correct specimen collection, accurate labeling, timely transport to the laboratory samples, specimen reception, policy of urgent samples, acceptance and rejection criteria, centrifugation, pipetting, aliquoting, sorting, etc., holding time. As we can see, all this area which really associated and related to the errors we presented in the previous slide and the key errors in the pre-analytical phase. As a quality indicator in the laboratory, definition of the objective measure that can be used to evaluate critical healthcare dimension like patient safety, equity, timeliness, and efficiency. QIs are tools that enable the quantification of laboratory performance based on objective criteria. So in the International Federation of Clinical Chemistry and Laboratory Medicine, IFCC working group on the laboratory errors and patient safety, they have identified around QIs quality indicator focused on the pre-analytical phase. A similar working group were established with the European Federation of Clinical Chemistry, EFLM. They have established the pre-analytical working group back in 2013 with the aim of improvement, harmonization in the pre-analytical phase across Europe, and the members societies there from Europe. We have successfully, by the way, in Saudi, formed a Saudi pre-analytical working group under the Saudi Society for Clinical Chemistry. We have successfully, that was happened back in 2015 in partnership with BD and under the umbrella of the Saudi Society of Clinical Chemistry. We have launched a couple of years back the first guideline for the pre-analytical practices and the best sample collection published in the kingdom as well in the region, and we translated even to Arabic in the coming year. Here's some other quality indicators. Quality indicators related to the pre-analytic. As you can see, the order entry errors, the blood products wastage, the patient ID wastage, and errors, specimen acceptability, blood culture contamination. It's one of the key issues which we're facing, and it's impacted both the diagnostic, the pre-analytic, the treatment, the analytic, and even the length of stay of the patient in the hospital. Customer satisfaction, turnaround time for transportation, turnaround time outliers, and turnaround time for troponin test. Now I'll be talking about the other quality improvement measure and how those practices can really help the improvement and reduce the error. We really have the lean tools, Lean Six Sigma tools. It's a very great tools to improve any process, specifically in the healthcare sector. In the laboratory, I've worked on a couple of projects. The results are really impressive. About simply, I will not go in details in this big table, but it's simply about waste management. The waste could be in the waste of resources, of reagent, of time, of motion, transportation, production, and about improve efficiency, reduce the variation. Whenever or as much as we will be able to reduce variation, be able to reach the goal of standardized, real accurate standardized procedure. One of the nice tools within the Six Sigma approach is the root cause analysis. Digging deeper in the root cause for each problem will lead to convert something like this to be well organized like this. We have so many issues we faced during our day-to-day, in specifically in the pre-analytical areas. If we catch every single issue and dig deeper in it, what is the reason? Why is this happening? How I could improve the happening? I will be able to shift something from like this to this shape. I have a high hemolysis rate, so I have to dig deeper in this reason, in this action, to open a lot of really uneven, unplanned activities or things beyond our thinking, why we do have a lot of hemolysis or rejection, let's say, or contamination in the blood culture area. This will lead us to the importance of the internal as well the external audits or the quality check, identification of the key issues. To be honest, in BD, we have faced this because we do quality check and we perform it to some hospital based on their need. And it's really helping them to keep a third eye on their practice. Even if we don't really feel that we're having an issue in the pre-analytical phase, it's not a problem at all or there is nothing wrong to have a third eye from every now and then, to look after the practice on a standardization way. So those question has to be, both based on a standardization procedure. You just benchmark the practice, your hospital with the other hospitals or with even the guideline when audit or quality control happened. Finally, basically the process improvement steps or the key steps we have initially to benchmark ourselves. We have to root cause analysis, and it's very important to dig deeper to the root cause of the issues. Change management and education. It's very important step. Without a key change in the management or the way how we manage the things, will not be able to really achieve the process. Optimize and control. To achieve the best and always improving, we need to identify clear goal. We need to analyze the current practice in the specimen collection in the area of pre-analytics, let's say, implement the corrective action and monitor and measure the effectiveness frequently. Other contributors to the quality, we have the external quality control or the ECAS system. We have the proficiency testing, technology and innovation whenever it's accessible and applicable to have technology and innovation. We need to adopt it. It's really helped to reduce human interaction, which will lead to reduce errors. Rational testing, test utilization, continuing education, competency development and enhancement. Talking about the management, which I believe it's one of the most important things we have. So as a definition, change management involves to the modification or the modifying of or improving of the process, either in the manufacturing activities or even human resource policies and guidelines. Change management consists of tools, process, and procedures that an organization uses to initiate, monitor, and implement modification in the processes. A traditional step in leadership management include preparing for the change. We have always to prepare the team, prepare ourselves, prepare the organization sometimes for the change, manage the change. Always change is not easy, and always a human by nature are resisting to change. So we have to manage, the way how we change, reinforce change in the organization, as we say. So change management in the working of healthcare system, we need commitment from organization. We need a strong leadership to drive the change, and we need a people capability to be improved and step up. Execution plan, a very robust execution plan has to be in place. Continue improvement and education. It will definitely facilitate and help in adopting the change or in the change management in the healthcare system. And finally, a good culture need to be always a key driver. So in summary of my presentation, so the laboratory diagnosis support over than 70% of the clinical decision in the patient management, even as I said, with a lower budget, lower than 5% of the hospital budget. The lab test life cycle is complex and tend to errors at all levels. A significant part of pre-analytical phase lies outside the lab and unfortunately beyond the laboratory and control sometimes. Approximately 70% of all the lab errors occur in the pre-analytical phase, and the bad thing that sometimes those kind of errors are even undetectable till maybe treatment is in place for the patient. Implementing international recognized laboratory quality standard is the best way to drive quality. Adopting quality indicators strongly support other quality improvements measures and bring measurable benefits. In ISO 15189 CAP or other accreditation program formalize the efforts and brings rewards for the clinical laboratory and the healthcare establishment. So I hope I did not exceed the time, and we come to end of my presentation. Thank you.
Thank you very much, Mohsi, for this comprehensive and elegant presentation. You took us through a lot of content, and you left it with a very considerable time for questions. So may I ask all the speakers to open their cameras? Yes. So we have a few questions. Reem?
Yes.
So probably this question I can direct it to you. The question is, if we don't have a histopathology lab, but histopathology or histo send out, if in 10% formalin is prepared in class 2 B2 safety cabinet, where dilution, dispensing, and sorting for use for histopathology department, mandatory to monitor formalin fumes level, and if so, how frequent?
Okay, so based on the OSHA requirement, there is a permissible exposure limit. So basically, the actual level means that the concentration must not exceed 0.5 per million part of air. Okay, so it depends when they prepare the formalin in the lab, how long they're exposed to the formalin itself, even if it's under the biosafety cabinet. So usually, a monitoring of the formalin must be done anyway. There is some exceptions, but they have to consult the OSHA requirement, because the exception is just mentioning that if the lab already know the exposure limit is below the action level. So they have actually to measure it.
Can you give them like how frequent they should do it? Should they do it like biannually? Periodically.
Yes.
So I guess biannually at least.
Sorry, but they have to repeat it each time they change the procedure or the process, or the person himself or herself new to the procedure itself. Again,
this is very important since it have a very health hazards. Therefore, monitoring this something essential for any lab. Mm-hmm. So the second question maybe for Mohsen. Can you give like a few examples about KPIs? Show some KPI reports as example and their corrective action.
I think the key KPI can be for the laboratory. Some of them are has to be related, or what we see actually in the hospital related to safety. So the number of incidents of needle stick injury, of tube breakage, let's say, and during preparation in the laboratory. The number of incidents of QNS, quantity non-sufficient, in the tubes during the blood collection. Hemolysis rate, definitely, it's one of the KPIs which has to be within the control, and the blood culture contamination. There must be things within the key KPIs for every single hospital, because the impact is really big, as well as the turnaround time. We have improvement today in the laboratory, bringing the latest automation machine and total lab automation, and we maybe forget, or we really don't focus that most of the waiting time are happening outside those instruments. So collection procedure, transporting the sample, waiting the sample, or preparation the sample in a proper way, waiting the serum to clot. So this taking very long time and need to be within a very proper control. The turnaround time should be one of the key KPIs for the pre-analytical improvements.
So again, another question for you, Reem. Again, because of this coronavirus epidemic, is it true that coronavirus infection affect lab staff by blood samples? And maybe another question that is related also to corona: can respiratory viruses infect through blood?
Okay, as far as I know, the respiratory viruses is known to be transmitted by contact or the aerosol or droplet. So regarding the blood samples, I'm not really sure.
Nevertheless, we should always have all the precautions up.
For the second question, for the coronavirus infected lab staff by blood sample, I actually read an article a couple of days ago. It's a study done in November 2020. It's a case report, and it was actually very interesting. It's a male patient. He was 21 years old, and he was suffering from aplastic anemia, and he needed platelets transfusion. So the person who actually donated the platelet was previously diagnosed with corona. He was COVID positive. So, but when they did the testing, the patient was actually corona negative. So, but still, the mode of the transmission of the viruses is still unknown.
So it's a mysterious, there's a lot of aspects of the coronavirus that we still lack. Maybe this is the last question because of Maghrib prayer. Again, Mohsen, another question for you. Can you provide more information about Six Sigma, since you have the black belt?
It's, to be honest, very big topic, which, I can really summarize it, or I'm happy to provide any needed information, maybe offline, to the person who requested the information. But it's a process, to be honest, it's a process engineering kind of tools and mindset process improvement, tools and mindset, and it starts with the yellow belt and end with the master black belt. So yellow, green, black belt, and then at the end, master black belt. It can, be involved in every single step. I always say that in my home, whenever you go even to the grocery store, if you really follow the Six Sigma principle, you're going to save time during your usually grocery in the shop. So you can imagine if we take the Six Sigma principles and apply it in the lab, how much improvement we will be able, and we will be able to talk about and reduce, it's all about reducing waste. And when we say waste, even a human could be waste. When I have 10 people doing maybe 7 jobs, so I need seven people to do those. I don't need 10. I can allocate 3 to do things more in a different area.
Another question by Abdulaziz Al-Ghamdi, related actually to the same. Which quality tool is better when to use to improve project about reduce the lab cost? The PDCA or Six Sigma?
To be honest, I prefer Six Sigma, but when we say about Six Sigma, we have to consider that there is no Six Sigma improvement project will be ending in a month or 2. So when you say about Six Sigma, you have to do it by book. So it should be a very comprehensive project. It's involved much more stakeholders. We need, and they have to be like between 7 to 9, the best team. And but it will give us a very comprehensive improvement plan, which sometimes can take a year to come out with a proper outcome out of the other tools. Could be maybe faster, smaller, but following a Six Sigma principles, it is really give better.
Maybe last question: how to be certified in Six Sigma? And probably the Saudi Society of Clinical Chemistry should invite you for a whole session.
My pleasure, sir. Getting Six Sigma, I heard you correct, from where we can get Six Sigma. So there is multiple providers, I believe, and there is even some universities are providing master course. And after you study master for maybe 1 year or 2 years, sometimes you will end up with a green belt. So it's something kind of comprehensive tools or solutions we can talk about.
So I would like to thank all of our speakers for a very interesting session. I hope that you have enjoyed it as much as I did. Again, to remind you, every session has to be registered independently to earn the CME hours. And again, please come back for the 3rd and final session with my colleague, Dr. Hisham Shams. He's going to be next. And also, don't forget our General Assembly at around 9 p.m. Very important for all of our members to attend this session. Again, thank you all for attending, and see you again in the 3rd session and the General Assembly. Thank you again, and see you soon.
Shukran, Doctor. Thank you. Thank you all.